Hey everybody, welcome back to the lesson. Instead of pausing my recording to write all this nonsense out, accidentally just stopped the recording, so we have to start over again. I already drew out this little like system over here. So I have two non-parallel lines that are cut by a transversal, which is a line that intersects two or more coplanar lines at different points. Is this an important definition for you to remember? Please don't bother. Like, it's not worth it. But what I am going to say is that we're going to talk about the relationships between all of these angles. Now, we kind of learned in class the other day, but this number one right here doesn't mean that it is a degree of one or anything like that. It's just labeling this obtuse angle as angle one. Okay. You also kind of saw this on your attendance check for recently this week too. So here's what I want you to think about this though, is I'm going to keep talking about this as houses. So I have this overlay. Don't worry about making it. Okay. But basically what I have is like, I have some train tracks. It's the transversal. It's not called that. It's called a transversal, but we have some train tracks. And then we have these houses on the street that are so close to the train tracks. These poor houses, they have very low, I don't know, like sleep because the train keeps coming through. But that's how we're going to talk about this, is about kind of like houses and stuff. So for instance, houses on the same street here, they can be across from each other in this intersection, or they can be in the same spot, but in the other intersection, you know, that kind of thing. So that's just how we're going to think about this. So we're going to do some vocab. Are you ready? Okay, so here is the first one, corresponding angles. These are all angle relationships, but I didn't want to write the word angle every single time. Nobody has that kind of time in their life. So corresponding angles are houses that are on the same spot but on a different street. So here are my options. So angle 1 and angle 5 are corresponding because they're in the same spot, but they're on a different street. There's 3 more. Pause and see if you get it before I do. Pause. Good job. Angle 2 and angle 6 is another one. Same spot, different house, or same house, different street. Angle 4 and angle 8, and angle 3 and angle 7. Oops, and angle 7. Did you get them? If so, high five. If not, do it right. Write down the right answers. This next part, normally what I do is I list out all the different relationships, but there's really 4 other types. They can be alternate or same side. So alternate means that they're on opposite sides of the train tracks, or same side means they're at the same side of the train tracks. So these ones are all same side and these ones are alternate, right? And they can be on the inside or the outside of the 2 streets. So they can either be on the interior or on the exterior. So I'm going to break it down like that instead, like this. I wish I had the cool editing skills to like snap and have it be there. I don't know. I follow some cool people. I'm not that cool. Not in math, in like makeup tutorials. I want this to be a cool makeup tutorial, but for math. Okay. Anyways, so what I'm basically doing is I'm saying like there's alternate interior angles. Okay. So they're opposite sides of the tracks and they're on the inside of those 2 streets. Let me put the streets back on there. Okay. So alternate, opposite sides of the track, interior on the inside of the 2 streets. So there's 2 options here that are both alternate and interior. These 2 are on the opposite sides of the tracks and on the inside of the 2 streets, or these 2, opposite sides of the tracks, same side of the 2 street, or inside of the 2 streets. So angle 3 and angle 6, or angle 4 and angle 5. Those are my 2 sets of angles that are alternate interior. Okay. They also could be same side interior. So they're on the same side of the tracks on the inside. So that's angle 3 and angle 5 and angle 4 and angle 6. Do you have to make and symbols like me? Don't worry about it. You can do little like plus things. I don't care. Don't do a plus because it means that they're being added together, but I digress. Okay, now let's move on to exterior. So alternate exterior angles are on the same side of the tracks right here, but are on, alternate opposite sides of the tracks, but on the outside of the two streets. So like out here or out here, they can't like wave at their neighbors inside. It's so sad. So alternate exterior angles would be like angle 1 and angle 8, or angle 2 and angle 7. So those are alternate exterior angles. And then same side exterior are on the same side of the tracks, but on the outside of the two streets. So that's angle 1 and angle 7, and it's angle 2 and angle 8. Okay? Is that a lot of matches? Yes. Is regular geometry only doing alternate interior and alternate exterior? Yeah. Does that mean we can't do all of them? No, we're so much cooler than that. And so what the whole point of this is that later, next lesson, we're going to tell you which of these add up to 180 and which of them are congruent if they're parallel lines, parallel streets. Okay. So right now they're not parallel, so there's no relationship. The only thing that is absolutely congruent when they're not parallel are vertical angles, which we've already learned are on opposite sides of an X, right? They're like kitty corner, if we still say that. They're the friend that you like jump out of the back of the house and then you like run across the train tracks and you go to their house. Like it's that kind of friend. These are the only ones, only pair that are always congruent. It does not matter. It does not matter if these are parallel lines, if they're weird lines, if they're skew somehow. That wouldn't make sense on a street, but if they were skew. So the only pair that are always congruent are across from each other in an X shape. So that's like angle 1 and angle 4. You want me to do it all? I can do it all. Angle 2 and angle 3, angle 5 and angle 8, and angle 6 and angle 7, because they are in an X shape across from each other. Those are the only pair that are always congruent, and no matter what, always congruent are vertical angles. We actually have a theorem called the vertical angle theorem that says that all vertical angles are always congruent. We're not going to get there yet. It's going to be next unit, I think, maybe the unit after. But that's the only thing that really matters here, is that vertical angles are the only thing that are always congruent. But next time, there's so many relationships between these when the streets are parallel, but only when the streets are parallel. So for now, I just want you to solidify these vocab words, which, by the way, are the last thing you need to complete your Geometry Town project. We are going to do some more quadrilateral practice in class because I know that's a little bit of an iffy thing. You know, my hand's like on the side here. Not all the way over. So that's the only thing that's a little bit iffy, but we'll be fine. Like, we'll figure it out together. We're going to do it in class, but you can totally finish your Geometry Town project right now and have it done. We're a little bit ahead of schedule somehow, so it actually should be due on like the 23rd, but I'm going to keep it on the 30th because I don't want to stress you out. You get some extra time. You're welcome. You're so welcome. I don't know how that happened, but it's okay. I have been talking too long. No, I haven't. You're good. By the way, sometimes, especially on your homework, I'm going to add like an extra line over here. There's going to be 2 transversals, which means that everything's a transversal, which means that there's a bunch of relationships. But don't let that stress you out. And if it does stress you out, talk to me. I got your back. Don't worry about it. Okay, bye.